Hello, everybody. We're going to be going over some more Teamcenter and NX stuff. It's probably going to be a bit of a long video, so I'll get right into it. I just reopened this NX with Teamcenter app, and I'm going to open up the vehicle assembly file and give a quick rundown on how the vehicle assembly file and vehicle layout file work. And then from there, we'll go more in depth about um, lower level files and how they operate. Okay, so here we go. It's all loaded up. Um, First thing to notice is, I guess one of the first thing to notice is the vehicle, the long axis of the vehicle that goes along the length of the rocket is aligned with the x-axis. This is pretty much because in aircraft, in airplanes and stuff like that, the fuselage lays on the x-axis, and rockets kind of inherited that uh, convention, and we're just following that convention for rockets. So you'll see that in industry pretty often. So that's one thing to notice. Another thing to notice is we have a bunch of different parts in here. These are all just mock-ups to represent what the rocket will look like. Like your fuel tank is this red cylinder. Your blue oxidizer tank is this blue cylinder. You have a mid-air frame with some very wide struts here in this aquamarine color. Some tubes in there as well. A nose cone, obviously, and then upper plumbing and upper airframe. And then down here we have some very large fins, some tubes, and then the rocket engine assembly. So just a bunch of mock-ups representing different subsystems making up the rocket, and we'll use those as demonstrators as we go through how to manipulate this CAD. Another thing to keep an eye out on, and this is something we'll mess around with quite a bit, is on the left-hand side of your screen, you'll see this ribbon, this vertical ribbon here. We'll be using a lot of stuff within the Part Navigator tab, and then also the Assembly Navigator, especially with this type of file where it has a lot of different subcomponents. We'll be using this Assembly Navigator tab quite a bit. And jumping right into that, if you look at the Assembly Navigator, you will see that there is kind of a tree-based system here where you have a tabs with different indentation levels representing how far down the tree they are. And then you also have these little plus and minus buttons that you can click to expand the tree out or condense it. So right now, the top of the tree, I don't know if that is like the roots of the tree or the branches or the highest branch of the tree. I guess it would be the roots. Is this L40000-500 file, which is actually the vehicle assembly file which we're in. That's the top of it, and then there are a bunch of other assembly files, each of which represent a different subassembly within the rocket. So if we kind of scroll through them real quick, we have the rocket engine, we have lower airframe, lower plumbing, the fuel tank, mid airframe, mid plumbing, the oxidizer tank, upper airframe, the upper plumbing, and then the nose cone. So kind of in ascending order as you work your way up through the rocket. And each one of these is a different assembly file for that system. And we can actually even expand out each one of these to show the different parts that make up it. So you can see the struts, the fins within lower plummet or lower airframe. You can also see if things are patterned around, which is going to be pretty common, I bet. You can see where that takes place and what exactly is being patterned by moving around this branch. Another very important thing that goes off of that is the make work part tool. So right now, you can tell that we're within the vehicle assembly file in this tree by looking at the bold color of this file name, and all the rest of them are grayed out. And we can move into different assembly files by right clicking on them and pressing the make work part. And what that'll do is it'll change what we're working on from the vehicle assembly file to now, I believe this is mid-airframes assembly file. But we can still see what's happening in the vehicle assembly file. It's kind of grayed out. And now you can see that we're actually working on this mid-airframe file because it's brighter, and then also over here in the assembly navigator, it's a bright white font, and the rest of the file names are grayed out, including the one that was previously white, the vehicle assembly file. So this is pretty cool, actually. We can move between files, and we can work on stuff within this file. Like if I wanted to change the circular pattern, it's not loaded right now, but I could do that by moving around in here. This type of navigation and maneuvering tool is going to be very helpful, in fact, in another vehicle level file that we'll go over in a little bit, but I just wanted to show you, give you a little intro into that. So I'm actually going to move back over to the vehicle level assembly file by making it a work part. And we're back to having the entire rocket in full color, I guess. So I'm going to open up the vehicle layout file, which is L4, and I'm just going to say asterisk 000, and then there we go, the rocket layout file. And you'll notice that this one is kind of different in appearance. It looks a lot more cluttered, and that's one of the big differences between layout files and assembly files. Layout files will be a lot messier, kind of crowded in a way, harder to load even than assembly files. The assembly file should be nearly one-to-one for the actual rocket we build. Should have every nut and bolt that we plan on putting on the actual rocket. And in this way, we can have a very good representation of what we're building. So if we need to see how much space we have to get wrenches into plumbing, or how heavy the rocket will be by accurately updating the material properties of all the components, we can get that through the vehicle assembly. But moving back over to this layout file here, another difference is you can see that there are a bunch of datums going throughout the length of the rocket, and along with those datums there are also coordinate systems pretty much at each of the datums. And these datums are used for a few things. The main thing is dividing up the subsystem boundaries. They basically serve as boundaries between different subsystems. So if I'm looking at lower airframe right now, which is comprised of 3 struts, 3 fins, and that's pretty much it, the lower boundary is set by this datum here, which is coincidentally, well, not coincidentally, it's purposely put right on the top of this injector body. And then the upper bound for the lower airframe is at the boundary or interface between the struts and the fuel tank. So they set the interface locations between different subsystems, and you can go throughout the entire length of the rocket and get a feel for it too. They just divvy up where the rocket subassemblies will be. And then the coordinate systems are also there to provide a reference point for the layout files, so that you have like axes to base your revolves around and so forth. They're just kind of there as if you need them to reference off of, you have them. Same with the datums as well. Part of the idea is if you need to, you can base your modeling and your feature making off of these datums. So when they change position, which they will be doing potentially, your models, your parts, your bodies move with those moving datums. And let's actually talk about how these datums can move and the use cases for that. So right now I'm in the assembly navigator, and I'm going to move over to the part navigator, and you'll see a list of a bunch of coordinate systems and a bunch of datum planes, each of them conveniently named, so you know what's going on. But there's also one singular sketch, and that's called the vehicle point sketch. And I'll open that up right now, and we'll take a look at it. So this vehicle point sketch is defining the lengths of the different subsystems making up the rocket, and we actually define the planes, the datums, based on locations of points within this sketch. So I can change the any of these named dimensions and have that change the relative positions of these datums to each other. So let's do a quick demo. Let me change the fuel tank length from 100 inches to 120 inches. And you'll notice that these points right here, this little guy, moved up by 20 inches, and all the rest of them also shifted upwards by 20 inches. So if I click finish, the datums will also make that move. You might be wondering why the tank didn't move to meet that datum, and that's what it's supposed to do. There are a few things you might have to do to make it update like that. We'll go over those. First of all, the thing I always forget, I've recorded this video probably 5 or 6 times now. I'm hoping they get better each time, but for 5 or 6 times, I've always forgotten to save after I made that change, because what we're about to do requires you to do it from a saved point. Otherwise, it doesn't really pick up on the change. You have to save it to Teamcenter for this change to be propagated. But I'm kind of getting ahead of myself. Firstly, let's explain what we're trying to do here. So I just changed the fuel tank length, but the geometry itself did not update while the datums defining the boundaries between the subsystems did. My goal is to do something within the tools of NX and Teamcenter to force everything to update to match up with these datums. So the fuel tank should have changed length to 120 inches. And so let's see if I can do something to make that change happen. Firstly, the reason why it didn't update automatically is I don't have these files loaded. As I said at the beginning, I just freshly opened up NX, and I didn't open up any other files between the vehicle assembly file and this vehicle layout file. So none of the other files, none of the other layout files or assembly files are loaded. And that's really the root of the problem. So to fix that, I'm going to go over to assemblies, and I'm going to go over to load interpart data, and I'm going to click it. So I click that, and then this little prompt came up. Make sure you have all parts in displayed assembly checked, and then open unloaded parents from all levels. And I'm going to zoom out here so you can actually see what's going on, because it's actually a very visual process, surprisingly. So I'm going to leave it there and then click OK, and we'll see what happens. And you'll see a bunch of things kind of shift around a little bit as that change gets propagated throughout all the subassemblies layout files. And there you go. Things change length. The fuel tank updated to be 120 inches rather, and everything else shifted upwards to match it. I can actually go into this vehicle assembly file, and I can check the length of the fuel tank just to double check that it made its way into the vehicle assembly file as well. There you go, 120 inches. There you go. So the change did propagate properly. However, and actually, one thing I didn't notice, but you might be able to go back and check this. But before, all these layout files were a darker gray color. Their font color was a little bit darker, but doing that process of load interpart data should have made these file font colors a brighter white, because that means we're loading in all these files, which is what makes that change propagate properly. Okay, so on one note that I should bring up, we shouldn't be changing the vehicle length all that often. Ideally, this is like maybe a once a month or once a week for the first couple of months thing, because there's actually a lot of potential chaos that can be formed by this, since we're making a very vehicle wide change when we make a change to where these datums are located. For example, I was working with another member to experiment with checking in and out files and making changes like changing the fuel tank length. And there's a lot of weirdness that happened. So to go more in depth, somebody checked out. I believe it was like I believe they checked out the fuel tank, and they were messing around with it or something, like changing the diameter of the tank, what have you. And I checked out the layout file, this file itself, and I had them make changes, and then I made a change to this fuel tank length, same as I did before, and I saved it, and they were unable to save their changes once I saved my changes, which means that any progress they made, if they were modeling a bulkhead or adding in ports, anything like that, would not be able to be saved to Team Center, since I had this vehicle layout file checked out and I made a change to it. So imagine that on a vehicle scale where you have a bunch of different people working on a bunch of different layout files for different subassemblies. If somebody came in here and changed the length and saved it, a lot of potential work could be lost. So that it's a matter of making sure that we announce when we're doing these vehicle level length changes, and making sure people have their stuff saved when we do it and everybody's aware that it's happening. Because it seems that any changes made to this layout file takes precedence over lower level layout files. I initially imagined that those layout files would kind of be immune to these changes because they're checked out, and that checkout process I thought was a little bit more robust, but it seems that this file takes precedence over those, which I guess makes sense when you think about it. But anyway, yeah, you can change the vehicle length and different subsystem lengths within this vehicle layout file, and that change will be propagated down if you do that process of either loading in all the layout files or doing the load interpart data thing. So that's one part of it. That's the vehicle layout and assembly files. Let's go into some more depth with a specific layout file. So what I'll do is I'll go in here and I'll open up, what's a good one? I think this is a good one. I'll open up mid airframe, and I'll actually open it up in a window, which means it'll, instead of making it a work part within this this vehicle layout file, it'll open up a new window that I can use specifically for the mid airframe without seeing the rest of the grayed out geometry. So now I'm within lower mid airframe, and there are a few things you might notice. First off, there are the oxidizer tank and the fuel tank already in here. And then there are a few datums and a coordinate system, and then this green tube looking thing. Let's start talking about the actually let's start talking about the datums because we already kind of talked about them before. These datums are the same datums that were defined in the vehicle assembly file. In fact, they're the exact same datums as these two right here, and then the coordinate system is that coordinate system. So you can kind of see the resemblance. And those datums are, I don't want to say imported, but they're linked in from this vehicle layout file from there into the mid-airframe layout file to be used as reference. And the way that's done is if you go to your assemblies tab and then hit Wave Interface Linker, and then you click on, you can either search or it's auto-populating for me, you can bring up the rocket layout file. And if you click on that down here in interfaces, you'll get a list of all the different things from the layout file that you can bring into your file that you have open. So what I did earlier is I defined a bunch of interfaces that can be referenced between files. And right now they're only the datums and coordinate system, since that's the only thing that I wanted to be moved around from the vehicle layout file. So let's say I wanted to bring in, for whatever reason, the nose cone coordinate system. I can click on that while I'm within the mid-airframe layout file, and I can click OK, and then it populates in this coordinate system. And if you look over to the Part Navigator tab, you might have seen this flash open. The linked datum coordinate system, nose cone coord, that was the thing I just linked in with that wave interface linker. And now I can use this, while I'm modeling for revolves or a datum to base my modeling off of. I'm going to delete that because I only included these two datums in that coordinate system for a reason, because those are the only ones you should really need, and having more stuff in there kind of gets noisy and isn't needed. It's good as much as you can to keep things minimalized. So that's why we have these two datums for setting an upper and lower bound for the system and this coordinate system, and you can see all that over here. So that covers the two datums. I might make another video about how to model within a layout file, and I could probably talk more about how I would use those datums in that video. But for now, let's move on to talking about these two propellant tanks and why they're there. Why they're there is a pretty intuitive answer, I hope. Imagine that there is some kind of bulkhead feature here, or bulkhead part. Right now it's just a cylinder, but you can imagine that there would be some kind of pad with a bolt pattern used to connect with a strut. And you'd have three of them along the circumference of this tank. You would want to be able to reference off of that strut pad, I'll call it, while you model your strut, right? Because you want to follow the same bolt pattern and have the same same dimensions on your strut that you do on the tank bulkhead. So that's why you want to bring in the geometry from the tank into this file here. Yeah, so that's why we want them in there. It gets a little bit more complicated on how to bring it in, because the easy way to bring it in doesn't really allow you to build off of the bulkhead or build off of the tank in a way that you would expect to do, where you kind of select this surface as a plane. It's, select this surface as a plane, and then do all of your things where you're using this as like a reference, like that, the way you would normally do that doesn't allow you to do it quite that easily. No. Let me show you what I mean real quickly because it will make it a lot easier to understand. So I'm moving over to the assembly navigator. Or first, actually, I'm going to hide these two linked bodies, and that kind of gives you a bit of a hint of what we're going to be doing. But back in the assembly navigator, I'm going to unhide these two assembly files. And these two assembly files are actually the oxidizer and fuel tank assembly files. So I brought those in here by going to assemblies and then adding component and then adding those assembly files in as you normally would. So let's imagine these were all the assembly files. I would just click on it, click OK, and import it in that way. However, this does not let you model off of that geometry. And I can show you what I mean, as opposed to what I did earlier where I was able to select this tank face and start modeling off of it. First off, I can't do that. I'm trying to select it. I can't. I actually have to selected the wrong thing there, but I have to select this datum, and that's part of the reason why the datums are there. But I have to select that datum, and then I also have to, I can't do the thing where I just highlight on the edge of this tank wall and make my line. It isn't able to reference off of that tank edge. There is one way you can do it and kind of cheat by projecting curve. That way you can actually bring in that line, bring in that curve, but let's ignore that for now because that kind of defeats the purpose of what we're doing. The main thing to note is I cannot use this edge in any meaningful way. I can't use the edge of the tank in any meaningful way while I model. And that could be a bit of a problem because imagine a bolt pattern on this surface. I can't reference off of the locations of where those bolt holes are. So let's try to fix that. Let's delete that. Okay, cool. So let's fix that. The way to fix it is by going into assemblies and then using this wave geometry linker tool. And what that'll do is it'll actually take the geometry from this assembly file that we added in via add component, and it will bring it in to the layout file we're working on in a way that we can reference off of it. And I just clicked on it, and you can see this little alert here that popped up saying that I already made this body already via wave geometry linker, and I'm only making a copy of it, which is expected because this geometry already exists. So if I click OK, and if I hover over the fuel tank, you might notice that we get some weird artifact stripey thing going on. You can really see it well on the top of the tank. It's a bit of a weird, visual thing. I don't like it, which is why I typically hide all the assembly files as soon as I bring them into the layout file, because if you do that, it doesn't, because right now, I guess the reason why is you have two of the same geometry, two of the exact same geometry cloned on top of each other. And since they're in the same location and the same shape, that overlapping creates some visual weirdness within NX. So in order to get rid of it, you have to hide one of the copies and only let the linked body that we just brought in with the wave geometry linker show up. So I just did that for the fuel tank. I can do the same thing again with this oxidizer tank. I click on wave geometry linker. I click on the oxidizer tank. I still get that warning because there is another copy of it from earlier, but I'll click OK, and then I get this weird visual glitch. But if I hide the assembly file, it'll go away because now I only have one copy visible. And then if I go back to home, and if I do some modeling, or actually let me show you real quick where those pop up. So these are the two linked bodies that appeared after I did that wave geometry linking. And then up here are actually two hidden copies of that come, already set up. I did these a while ago, so, but these are the two that I just did right now. But let's do a little, before and after extrude to show you what I mean by being able to reference off of the geometry I wave linked in. So first off, I can click on this this fuel tank, end cap, bulkhead, whatever. I wasn't able to do that before. And then the other big thing is I can now, reference off of the edge of the fuel tank, which is another thing I wasn't able to do before. But regardless, we'll get rid of that. And I will actually also get rid of those two and make those other linked bodies visual. Yeah. So that is how to wave geometry and link stuff in. I went through all the different layout files and I wave geometry linked things that made sense into them. So like right now, I only have the fuel tank and the oxidizer tank present and referenceable in this layout file for the mid-airframe, because it doesn't really make sense to bring in the geometry from the fuel inject or the engine injector, because it's all the way down there and you're never going to need that if you're modeling the mid-airframe. So it's kind of irrelevant. It's in the noise. It'll just be there to clutter stuff. So let's concentrate on the things you need within your layout file so you can concentrate on what matters. So that's the basic mindset, I guess, that you want to have, is only wave geometry link in stuff that you'll actually need to model off of, and otherwise keep it simple and ignore stuff that you won't be touching. So if you ever feel like you need to bring in more stuff, that process of wave geometry linking, well, first off, before you wave geometry link, you have to actually bring in that assembly file that holds the geometry you need to wave geometry link. And you do that via add component, and then you add the assembly file containing the geometry that you have or that you want to include, and then you wave geometry link that body within the assembly file. Hopefully that makes sense. That's a lot of very similar sounding words stacked up, but that's how to bring in external geometry, I guess. Another thing to look at is these two files we explained, these two highlighted. We explained what they are. They are the different propellant tanks that we used to wave geometry and link geometry in. You can actually expand them out and see the individual part files, which are these -1001 files. But we didn't explain what this file is, and this is actually the assembly file for mid-airframe. So right now we're within the mid-airframe layout file, and within the mid-airframe layout file, we store the mid-airframe assembly file. And going back a little bit to previous videos, the assembly file is where you do all of your bringing the parts together into a cohesive unit. It's where you build stuff up into what it should be in real life. The layout file is where you do your modeling. The assembly file is where you bring the parts together into a cohesive unit via, if you're bringing in nuts and bolts, you would use them to fill in any bolt holes that you have that you would leave blank in your layout file. So you might be wondering, why do we have the assembly file under this layout file in this part tree? Why do we do that? Why do we not just have the assembly file completely separate and broken off from this part tree and doing its own thing? Or why don't we not have the assembly file be the root of this part tree and the layout file be one of the branches under it? these are all good questions. The main reason why is we can use the power of the make work part and the wave geometry linker to save a lot of time by making parts without having to move between files, move between these tabs a bunch. That's one of the reasons. Another reason is it helps a lot with loading parts and loading files. So going back to when we were messing around with this, I had to do this load inner part data tool to propagate a change throughout a ton of different layout files. And that change automatically made its way to the vehicle assembly file. And part of the reason why that happened the way it did, and why I didn't have to go into this vehicle assembly file to redo this load inner part data tool, is since I have the subassembly assembly files within the layout files for different systems making up the rocket, if I update the layout file, it automatically updates this assembly file because it is included in this layout file. It's a little difficult to, it's a little abstract, so it can be a little hard to explain, but since the layout file contains the assembly file, if I load the layout file, it's able to, I don't think it necessarily loads the assembly file, but it is able to update the assembly file via the load inner part data. But mostly we're going to be working with the make work part to maneuver around these files and make it a lot easier to make parts. So let's get past the explaining things verbally, and let's use some examples to demonstrate it. So right now I'm within the layout file for mid-airframe, and I'm going to go into the assembly file. So I'm going to click on it, right click on it, make work part. I'm not going to click the open in window. I want this to be within this window. And once I do that, you can see it grayed everything out, which is what we were expecting. And if I expand this out here and make this part, which is the mid strut, visible, you can see that it now populates it with three struts. In the layout file, we only had one. The reason why we only had one strut within the layout file is you don't want to model the same strut, which could be very complicated in its modeling. You don't want to model it 3 times. You want to model it once and then take that geometry and pattern it to make up the other 2 struts that are identical. And the way we do that is we first break off that strut into its own part file, and then we component pattern it to make the other 2. So that little detour about how that works, that's where this this component pattern, circular pattern comes into play. If I actually go straight into, so right now I'm in the assembly file within the layout file. Let's go down a layer deeper, layer down this part tree, and go into the part file for this strut. So I'm clicking make work part, and you can see that only one of the 3 struts is still a saturated color. The other 2 got grayed out, and that's because we're now within this. This is the original strut, and the other 2 are the patterned ones. So you don't do any modeling within the part file. You do it within the layout file, but you can still move down to the part file if you ever need to export or make a drawing for a part. You would do that within the part file itself. But 99% of the modeling happens within the layout file. But again, making work part is a very, very powerful tool to maneuver around the files, and I'll give you a quick demonstrator on how you would use that to make a part. Firstly, though, it's really annoying me that oh, I'm still within. Okay, I just lost myself a little bit. I'm still within the assembly file. I was looking for the extrude that defined this strut, but since I'm within the assembly file, since this is my active work part, I can't see that. So I actually have to move a layer up by making the layout file the work part. So clicking on that, and I can go into the part navigator, see the strut, and I want to make this strut thinner. It's really bothering me that it's like 3 inches thick. So I'm going to do that real fast, and you can actually use this as a demonstrator on how the changes will propagate. So let's say 0.75, and then click OK, and then not only did this one strut update, but the other two also updated, which is because we have the assembly file within the layout file. And I'm actually going to hide this assembly file. I find it to be kind of distracting because it's just not needed. It's only there. This assembly file is not there for you. It's there to allow, well, it's there for you, but it's mostly there to allow things to properly propagate and update. It's not there for your visual reference, rather. So I keep that hidden. You'll only see one strut. You'll leave the visual appearances for the subsystem assembly file because that'll be completely up to date. However, ignore that. That's another tangent. So we have a strut here. We probably also want some kind of paneling to keep the aerodynamics of the rocket efficient, or keep stuff in, whatever your reasoning is. So let's actually make that part. I'm now within the layout file for mid-airframe, which means I can do modeling in here. So let's do that. I'm going to use this datum, this lower datum, as my building off point, I guess, but I'm going to project curve. Actually, I guess I'll do things properly. I was going to be pretty lazy about how I did this, but let's do it a decent way. Probably not the best way, but a decent way. I'm going to put in 2 reference lines. I'll make a video at some point about how I model stuff. It's not necessarily the right way, but it's a way. And I think it is sometimes helpful to just break out of your bubble a little bit and see how other people do their CAD stuff. I know every time I see somebody else do CAD stuff, I pick up a few things, so that'll be another video. But for now, I'm using 2 reference lines that I'm going to actually declare as being 120 degrees apart from each other, since we're going to have 3 panels. So there you go, and then I'm going to set this curve that I made equal in radius to this fuel tank radius. And then I'm going to click finish. I'm not even going to make it a thick body. I'm actually just going to keep it a surface. And then for the extrude distance, I'm going to do until extended. And then I'm going to click on this upper datum, which sets the extrude distance to be within these 2 datum planes. So if they ever change lengths, the extrude will change length with it. Otherwise, I'm going to click, or actually body type, I'm going to make a sheet because it doesn't have a thickness. So there's our new panel. However, one more thing I'm going to do is rename the extrude. So I'm going to call it panel. And this is something I will be quite passionately for, is naming all of your features. I know it can be pretty painful to do, especially if you have a very complicated part that you're modeling, but it is very worth it. It's not only worth it for you as you go through your modeling tree of like 100 different features and have to find the one, the one extrude that you did a week ago and change one value for it. It's not only useful if you know which one you need to search for, it's also useful for other people who may be checking in on your part to see how things are done or make a change. It's like commenting your code. It's a pain to do, but it's really worth it. And so, as you're modeling, make sure you do all of your proper naming of features. This is even a little bit too vague for my liking, but you can use your judgment. So that's named properly. I'm going to quickly change this color to make it look a little bit nicer. Let's see, a nice. Yeah, that's fine. Okay, so there's our pattern panel here. But however, if we go into the vehicle assembly file, we won't see that panel, or rather, we won't see that panel represented at all. And that's because currently it only exists, well, actually, if we go into the vehicle layout file, it does exist because the vehicle layout file is comprised of all the layouts of all the different subsystems of the rocket. So it does see that, but however, it does not see that in the vehicle assembly file, which we want it to be able to see. So how do we do that? Well, the main step we're missing is making this panel a part. So right now it's a feature, it's modeled, it's a body, but it isn't a part with its own file to live within. We go into the assembly navigator. If we go into, the assembly for mid-airframe, we can see that there is a mid-strut part, which is a -001 or really number file. And this is actually the one that I was in before. It only houses this strut. And actually, if I make it a work or open it in a window, we can get a better visual on that. So this is the only thing within this file is this strut, this singular strut. And we want to do that for all of the different files, or all the different parts we model. So we would do that for a bulkhead, we would do that for a piston head, or a panel like this, the nose cone tip. All the stuff we model should exist in its own part file. And the way we set this up makes it very simple to make those part files. So first off, let's move back into the layout file as we would be when we model it. And then once we're there, I'm going to immediately have us move into this assembly file that lives within the layout file. So once we're in here, we're going to go into assemblies. We're going to click new component. And what this will do is it'll take us to a file creation prompt that you'd see if you were to click on, new file or whatever it is, because we're making a new file for this panel to live within. So let's click on the ID and let's say L40006 because we're still within the mid-airframe stuff, and I'm going to do -0 or -002 because we already did a 001 file for this strut, so we're incrementing 1 for the panel. I'll double click the revision, and then for the name I'll call it mid panel. I don't really know a good format for this name yet, or a good convention, so I've kind of just been doing all caps. I don't know if that'll stick, but regardless, make sure it defaults to model in inches, but make sure it's set that way as well. And it'll pop up with create new component, select object. You don't want to select anything, just click OK, and then you'll see this pop up on the left within the assembly file. So this is the new mid panel file that we just made. However, there's currently nothing in it. And we will make this the work part, and we'll see that there's no brightly colored part. Certainly not the panel is brightly colored. So we need to populate this part file by using Wave Geometry Linker. And this is part of the reason, this is a big reason why we use the assembly file being within the layout file, is so we can easily bring in this geometry. Since it's grayed out but still selectable, we can click on it, click OK, and now we just populated the panel part file with the actual panel geometry that we modeled within the layout file, while it is still within the assembly file. It might, it's a bit tricky because there are a bunch of things going on, but we're currently within the assembly file for mid-airframe, while within the layout file for mid-airframe, we were just able to populate a part that now exists within a part file for the mid panel, and it automatically is included within the assembly file for mid airframe because we did a new component, which is the equivalent as add component, instead of which we're pulling from a new, or pulling from a pre-existing file, we're making a new one. Okay, so to show what I mean a little bit more clearly, I'm going to move back into, I'm going to move up a level into the vehicle, or the, sorry, not the vehicle, the assembly file for mid-airframe, and you can see that now this this panel is still saturated, and if I go into, I'm going to move all the way over to this tab, which is the vehicle assembly file. You can also see that panel, which was previously not there, now show up. So that was a very quick and easy thing that we were able to populate a part file and have it automatically be included within the subsystems assembly file, and then also the vehicle level assembly file. And one more thing I'm going to do while I'm still having this mid-airframe assembly file as my work file, my work part, I'm going to go in and pattern it just like I did with the strut. So I'm going to click on pattern component, I'm going to click on this panel here. It's going to highlight that part file. I'm going to click on the vector from the mid-airframe coordinate system that was linked in earlier. I'm going to click on that. X-axis, yes, defaults to 360 and 3, which is good. And then there you go. Now you have 3 patterned panels, which is as it would be on the vehicle. And then I'm going to move back into the layout file, and I'm going to hide the assembly file because, again, it gets a little bit crowded. If you see this all the time, it kind of gets in the way. So I'm going to hide that. We're left with just the strut we modeled and just the panel we modeled, and everything will now update. If we change the panel shape or whatever, it will update the assembly for mid-airframe and also update the assembly for the rocket. So there you go. The change was also propagated up here. So that's how you would make a file, and it's pretty powerful once you get the hang of it. So let's see, anything else I want to cover? Let's do one more quick demo on how to make a part, just so we can get some more experience with it. But other than that, I think that'll be it for the most part. But one more thing to do. Let's say I wanted to add in some kind of manifold block within lower airframe, or lower plumbing rather. Let's say I wanted to add in a block right here that does something with the fuel and oxidizer lines. Right now I'm within the vehicle assembly file, which doesn't lead me anywhere to where I can model it. Only has assembly files. So let's move into the vehicle layout file. And I apologize if I've been sounding a little bit congested. My allergies have been acting up quite a bit. But now we're within the vehicle layout file, which is this 00-000 file. And this has all the layout files for the rocket. And I can go through and I can find, I believe this is the lower plumbing layout file. So I'm going to open in Window, and that'll bring that up with just the lower plumbing file. So you can actually see all the geometry I pre-existingly wave geometry linked in. These are all the, actually let me hide that. These are all the assembly files for, I believe this is the injector. This is for the injector, and I wave geometry linked in the injector from that because we want to reference off of it. This is the fuel tank. You can see that stripe patterning as I unhide the original fuel tank from the assembly file. That's there. Let me hide that again. And then this is the lower airframe, which if I unhide it, you can see both the struts and the fins. I only wave geometry linked in the struts because I don't imagine that I would ever need to reference off of the fins when I'm working on lower plumbing. There could be a case where you do, but I don't think you'll ever need to deal with the fins if you're working on the lower plumbing system. So I didn't include that when I wave geometry linked in stuff, and I just did the struts. So I don't have to, work around these big orange blocks in my way, because that'll get a little bit annoying. Again, simplify as much as you can to make it easier on you to understand what's going on. And then also, of course, we have the lower plumbing assembly file stored within here as well, also hidden because we don't really need to see that as we go through our regular modeling process. Okay, cool. So I said I wanted to add in a manifold about midway through the airframe section here. So let me make a datum plane, and let's say I want it to be exactly in the middle of these two datums. So I'll do a bisector, I'll hit those two, click OK. I have a new plane. Again, this is the layout file, so I can do a lot of modeling tricks in here. I can add new datums and stuff, not really worry about how messy it gets, because that messiness will not make its way up to the assembly files. Only the parts will make their way up. And let's say I'm a really good engineer, and I'll even name this manifold datum, because it'll make it easier for me to delete it later when I get rid of this example piece. So I'm going to create a sketch on this plane as one would, and I will make a very simple, it's a little bit, you can even, if you ever feel like you need to, you can hide stuff. Like I can hide this fuel tank mock-up linked body because it's getting in the way a bit. And I can orientate view to sketch so it aligns up properly. And let's make it that type of rectangle. Then I'm not even going to constrain this in any way. I'm just going to leave it. Oh man, how to do that? That's weird. Oh, geez. Okay, try number 2. I'm not even going to constrain anything because this is a demonstrator. Oh man, why is it doing that? That's weird. Oh wait, actually no, that's just the dimension thing in the way. I thought these lines were disjointed because that grayed out area was covering up the line itself. I think that's just a visual thing. So there we go, there's our manifold, and I'll call it, instead of 30 inches, I'll call it 2 or 3. Yeah, that's fine. And this is going to be new body, so we're going to have the Boolean set to none here. And there's our manifold. And I will assign it a feature color. Let's make it purple, because it's mixing the blue and the red. Yeah. Okay, so there you go. There's your manifold. It's a new part, so we have to make it a part file. So let's go into the Assembly Navigator tab. Let's move into the assembly file for lower plumbing. Let's make it a work part. You see everything else, everything gets grayed out. And then besides these two tubes, which were already populated and already have their own assembly, or already have their own part files, fuel tube and aux tube. So let's make one for this manifold here. And we'll do that by doing a new component, carefully double clicking on that and doing L4 0004-00, incrementing 1 up from this 3 gives us a 4, and then I will call this manifold. Again, a more descriptive name would probably be helpful here, but again, demonstrator, click OK from that, and then I will move into this part file that we just made, this manifold part file. I'm going to move into it, make it the work part, and everything else is grayed out because this part file is not populated by any active geometry. But I will do that by hitting this wave geometry linker and then clicking on this manifold that we want to bring in. And now it's a saturated geometry or saturated body, I guess, and this part file is now populated. So I'm going to move back out into the assembly file where we can see all 3 of these part files saturated in color. The rest of them are grayed out. I'm going to move back a bit to the layout file, and then once I do that, I'm going to close out this tree, close out that branch, I guess, and hide it, because otherwise we get that weird overlappy pattern stuff. So I'm going to hide it. I'm going to click save here. I'm going to click save here. It's going to update, and then if I go to the vehicle assembly file, you now see that block. You don't see the datum because I didn't bring that over. I didn't link that datum that I used to base the sketch off of. I only linked in the geometry I made, and that's pretty much it. That's how you make parts within the system. It's pretty easy the way it's set up. You just have to know where you are within your assembly navigator tree. I think that'll be the biggest thing, is just being aware of where you are, because if you fall off the bus a bit, it can be pretty messy to get back on. If you start wave geometry linking stuff all over the place and not in controlled ways, in an organized way, it can be a little bit messy. So let's be mindful about that. Whatever is the brightest color or the brightest white. I guess I have the dark mode turned on. I guess it would be the darkest black. That's your active part. That's your work part. If you wanted to change where you are, you right click and then make work part. And then I'll go over how to include off-the-shelf parts and all that other fun stuff in another video, but I think that's a good place to end it. Let me know if you have any other questions, and yeah, have a good one.